Hello everyone. So welcome to lecture number 5 of Coulomb's law numerical part 2. So in today's class we will discuss remaining numericals based upon Coulomb's law. So it is given two identical metal spheres having unequal and opposite charges are placed at a distance of 0.90 meter apart in air. After bringing them in contact with each other, they are again placed at the same distance apart. ଯେତେବେଳେ ସେମାନେ conduction processରେ or contact କୁ ଆସିଲେ ସେମାନେ then same charge will appear on both the sphere. The same charge will appear means after contact their charges are equal, let it be q, and they are at a distance of 0.90 meter. In this case they are again placed at the same distance apart. Now the force of repulsion between them is 0.025 Newton. So given force of repulsion F is equals to 0.025 Newton. This is equals to 25 into 10 to the power minus 3 Newton. So calculate the final charge on each of them. Okay. So in this case the Coulomb force becomes F is equals to K Q square by R square. Both the spheres are having same charge. So F value 25 into 10 to the power minus 9, 20 to the power minus 3. K value 9 into 10 to the power 9 into Q square divided by R square means R is your 0.90 meter. That is 9 into 10 to the power minus 1 meter. Okay, I hope it is clear to all of you. So you can write 9 into 10 to the power minus 1 whole square. So after solving you will get 25 into 10 to the power minus 3, that is equals to 9 into 10 to the power 9 into q square. आज हम देखिबा केमती न्यूमेरिकल को बिट बाय बिट सॉल्व करिबा. So 9 into 10 to the power minus 2, that means 9 into 9, that is 9 square, then 10 to the power minus 2. Then we can cancel out 1 9 from this and remaining things will be, so 25 into 10 to the power minus 3, this is equals to 10 to the power 9 plus 2, that is 11 into q square divided by 9. So q square will be 25 into 9 into 10 to the power minus 3 divided by 10 to the power 11. This is the value of q square. This is equals to, q square is equals to 25 into 9 into 10 to the power minus 3 minus 11, that is 25 into 9 into 10 to the power minus 14. So this is the value of q square. So q value will be root over of 25 into 9 10 to the power minus 14 root of, that is equals to 5 into 9 root over is 3 10 to the power minus 14, that is minus 7. So this is equals to 15 into 10 to the power minus 7. We can write it as 1.5 into 10 to the power minus 6 Coulomb. Okay, this is the value of, as per the question. Calculate the final charge on each of them after conduction or contact. Final charge on each of the sphere will be 1.5 into 10 to the power minus 6 Coulomb. I hope question number 1 is clear to all of you. Next, this is our question number 1. Okay, next come to question number 2. So question number 2 is, in a hydrogen atom the distance between the electron and proton. So this is the orbit of electron and here is our electron and this is suppose the proton. This is your electron. The distance between them is r. So given r is equals to 5.3 into 10 to the power minus 11 meter. So calculate the electrical force of attraction between them. Fe is required. So Fe is equals to Ke, Coulomb's constant, then charge of proton, charge of electron, magnitude divided by r square. So it will be 9 into 10 to the power 9. It is a very simple question. Charge of proton is also 1.6 10 to the power minus 19, and this is also 1.6 into 10 to the power minus 19 divided by r square means r value 5.3 into 10 to the power minus 11 meter, that is whole square. So after solving you will get, after solving the answer will be 8.2 into 10 to the power minus 8 Newton. This is the answer. Okay, so this is about your question number 2. It's a very short question actually. Next, come to our question number 3. So calculate the Coulomb force between two alpha particles separated by a distance of 3.2 into 10 to the power minus 15 meters. So what is the charge of alpha particle? So charge of alpha particle, first thing, q alpha is equals to 2e, double positive charge is helium ion. So 2e into 2 into 1.6 into 10 to the power minus 19, that is equals to 3.2 10 to the power minus 19 Coulomb. Yes. So separated by distance, r is equals to 3.2 into 10 to the power minus 15 meter. So find the Coulomb force between them. Okay, so it seems to be easy actually. So F is equals to, Coulomb force between them is equals to Ke q alpha whole square divided by r square. So it will be 9 into 10 to the power 9. Charge of alpha particle, that is 3.2 10 to the power minus 19 Coulomb, its whole square, divided by separation is 3.2 into 10 to the power minus 15 whole square. So we can solve it in this way. We can write 9 into 10 to the power 9 into 3.2 whole square into 10 to the power minus 19 to the power 2, that is minus 38. Yes, divided by, it will be 3.2 whole square into 10 to the power minus 30. So 3.2 whole square, 3.2 whole square, we can cancel them. Okay, so remaining things, 9 into 10 to the power 9 plus 30 minus 38, that is 39 minus 38 is 10. So 9 into 10 to the power 1, that is 90 Newton is the answer. As per the given question, 90 Newton is your answer. This is the answer of question number 3. Yes, next is our question number 4. 2 point charges Q1 and Q2 are 3 meter apart. That means distance of separation between them is given 3 meter apart. Their combined charge is 20 microcoulomb. So that means it is a very important question. Q1 plus Q2 combined charge, that is 20 microcoulomb. If one repels each other with a force of F is equals to 0.075 Newton, that is equals to 75 into 10 to the power minus 3 Newton. What are the two charges? That means find the value of Q1 and find the value of Q2. So this is the mentioned question. So as per the given data, we can write F is equals to K Q1 Q2 by R square. That means from this we can calculate the value of Q1 into Q2. So Q1 into Q2 will be F R square by Coulomb's constant Ke. So F R square means that is 75 into 10 to the power minus 3. R square means we can write 3 square. Yes, divided by 9 into 10 to the power 9. Yes, that means we will, after solving we will get 3 square is 9 and this 9 gets cancelled out. So this will be 75 into the result of product of Q1 and Q2, 75 into 10 to the power minus 3 minus 9, that is minus 12. This is the value of Q1 into Q2, and in given question it is given Q1 plus Q2 is 20 microcoulomb. Okay, 20 microcoulomb. So finally from this data we can calculate the value of Q1 minus Q2. How? We know one formula is there, Q1 plus Q2 whole square minus Q1 minus Q2 whole square, this is equals to 4 Q1 into Q2. A plus B whole square minus A minus B whole square, that is 4AB. So from this Q1 minus Q2 whole square is equals to Q1 plus Q2 whole square minus 4 Q1 into Q2. So Q1 plus Q2 value, that is 20 microcoulomb. So 20 micro means 20 into 10 to the power minus 6, yes, whole square, minus 4 into Q1 Q2, its result is 75 into 10 to the power minus 12. So this will be 20 square is 400 into 10 to the power minus 12 minus 4 into 75, that is 300 into 10 to the power minus 12. Yes, so this will be, if you will take common 10 to the power minus 12, then 400 minus 300, that is 100 into 10 to the power minus 12. Keep it like this. So this is the value of Q1 minus Q2 whole square. Then what is the value of Q1 minus Q2? So from this we can calculate Q1 minus Q2, root over of 100 into 10 to the power minus 12, 100 root over is 10, and 10 to the power minus 12 root over is minus 6. So the value of Q1 minus Q2 is 10 micro. Q1 minus Q2 value is 10 microcoulomb. So now we have Q1 plus Q2, that is equals to 20 microcoulomb. Yes, so now we can write Q1 plus Q2, that is 20 microcoulomb, and Q1 minus Q2, that is 10 microcoulomb. देखो न्यूमेरिकल को सॉल्व करिएटा एक्चुअली टाइम टेकन तुमको लगे केतबेले जे तुम कैलकुलेशन स्पीड न करिवो. सो कैलकुलेशन को ठीक से पकेबार अछि. So after adding we will get Q2 cancel out. So 2 Q1 is equals to 30 microcoulomb. So finally Q1 value is 15 microcoulomb. So what is the value of Q2? So Q2 is equal to, from this equation, Q2 is equals to 20 microcoulomb minus Q1. So Q2 value will be 20 microcoulomb minus Q1 value is 15 microcoulomb. So the answer will be 5 microcoulomb. Yes, 5 microcoulomb is the answer of value of Q2. So this is the value of Q1 and Q2 as for the given question. Okay, I hope it is clear to all of you. Okay, so this is about our question number 4. Next come to question number 5. Yes, it's a very important question actually. See, so two fixed point charges plus 4e and plus e units are separated by distance a. So this is your diagram. So this is suppose plus 4e and this is plus e, and they are separated by a distance of a. Where should be a third point charge be placed for it to be in equilibrium? बोलो बता. যদি এটি দেলা থার্ড চার্জ কোট রহিলা মানে সে ইকুইলিব্রিয়াম রহিব. প্রিভিয়াস পার্ট 1 রে আমি এই টাইপর न्यूमेरिकल করছে. क्वेश्चन नंबर 3 4 शायद एमती रहिथियो. ठीक अछि. 4 5. So question number 4 and 5. So दुटा लाइक चार्जेस असंदी. One is your plus 4e means charge with greater magnitude, another one is charge with smaller magnitude. So ମୁଁ କହିଛି already equilibrium point ଟା कोट रहिबो nearer to charge of smaller magnitude. दुटा लाइक चार्जेस में ताको भितर रहिबो पॉइंट टा. So let this point is बस. This is your suppose a point A, this is B and this is C. Where should a third charge particle be placed for it to be in equilibrium? Let the third charge particle be small q. So now देखो a plus 4e ये केस रे plus 4e q को कौन करिवो रिपेल करिवो. Yes, so this is the direction of force on C due to a vector, and plus e starts to repel plus q along this direction towards LHS. So this is the direction of force on C due to B vector. As the third charge particle q is in equilibrium, that means FCA vector magnitude equals to FCB vector magnitude. Yes, so now simply calculate FCA in between C and A, that is KE Coulomb's constant. First charge is 4e into q divided by the distance. Okay, we have not mentioned the distance actually. Let C to B distance is x. So that means the distance from C to A, that is your A minus x. So the answer will be, so FCA, the distance is A minus x whole square, that is equal to FCB. FCB value in between C and B, that is KE. So one is your E, another one is Q divided by that is x square. Now k cancel हेले देखो q small q cancel, e then e cancel out, then ke ke एमान सब कैंसल हो गले. So remaining के रहला देखो 4 divided by a minus x whole square is equals to 1 by x square. Then square root नहीं जा both side रो. So 2 divided by a minus x is equals to 1 by x. So after cross multiplication, after cross multiplication you will get 2x is equals to a minus x. So 2x plus x, that is 3x is equals to a. So finally x is equals to a by 3. Okay, so this is the distance. The distance x is from plus e charge. Okay, so from charge plus e. Okay, this is the answer. So from charge 4e, the distance will be a minus x. Okay, so from charge 4e we can calculate from charge 4e the distance is a minus x. Distance is a minus x, that is a minus a by 3, that is also 2a by 3. Yes, I hope this question is clear to all of you. This is about question number 5. Then next come to question number 6. Yes, so two insulated charged copper sphere A and B have their center separated by a distance of 50 cm. This is R. R is given 50 cm. Then what is the mutual force of electrostatic repulsion? F is required. If the charge on each, then Q1 equal to Q2 equal to Q, it is given 6.5 10 to the minus 7 Coulomb. The radii of A and B are negligible compared to the distance of separation. That means a total last line show korchi A and B are point charges. They are point charges. Okay. Yes. So let's draw the diagram and start to solve the question. So these are 2 point charges and the separation between them R is given 50 centimeter and Q value both are having same charge. Okay, we have to find the electrostatic force of repulsion between them. So mention the given data. So given R is equals to 50 centimeter, this is equal to 50 into 10 to the minus 2 meter. Yes, yes. Okay, next is this is equal to 5 into 10 to the power minus 2 plus 1, that is minus 1 meter. Next Q1 is equals to Q2, that is Q, it is given 6.5 10 to the minus 7. So this is 6.5 into 10 to the power minus 7 Coulomb, and F is remain question mark. So as per the equation, F is equals to Coulomb's constant into Q square divided by R square. Coulomb's constant value is 9 into 10 to the power 9. Its value is 9 into 10 to the power 9. Yes, into Q square, that is 6.5 into 10 to the power minus 7 square divided by R square is 5 into 10 to the power minus 1 square. Yes, so how to solve this question now see. So it can be written 9 into 10 to the power 9 into, we can write it as 10 to the power minus 7 square, that is your 10 to the power minus 14, and 6.5 square means 6.5 into 6.5 divided by we can write 5 into 5 into 10 to the power minus 2. So if you will solve, then 6.5 को जब हम 5 रे कट करिबा, then it will be 1.3. again this number will be 1.3. yes, so 1.3 into 1.3, এটা हमर केते 13 square la 169. So this will be 1.69. So final answer will be 9 into 1.69 into 10 to the power 9, then tole minus 2 अछि उपरु गला plus 2 minus 14. Yes, so 9 into 1.69, take it as nearly 1.7. So 9 into 1.7 into 10 to the power 9 plus 2 11 minus 14, that is minus 3. Okay, then this is equals to 15.3 into 10 to the power minus 3, that is 1.5 into 10 to the power minus 2 Newton. This is the answer. Okay, पास 15.3 into 10 to the power minus 3 न लिखी 1.5 into 10 to the power minus 2 लिखली सो दैट एटा ऑर्डर ऑफ मैग्नीट्यूड फॉर्मेट a into 10 to the power b फॉर्मेट रे हम सदा रिप्रेजेंट करबा एंड व्हाट इज a एमती गोटे नंबर लिखिबा जेमती कि डेसिमल प्लेस गोटे नॉन जीरो डिजिट पर रहथुबो ओके सो एठी देखो डेसिमल प्लेस गोटे नॉन जीरो डिजिट पर अछि 15.3 रे डेसिमल प्लेस दीटा नॉन जीरो डिजिट पर अछि ओके सो दिस इज द आंसर yes this is about your question number 6 okay next come to question number 7 this is our question number 7 so two balls having equal positive charge capital Q on each are suspended by two insulating strings of length L meter from a hook fixed to a stand suppose this is the stand ओके ये दीटा आमर कौन पॉजिटिवली चार्ज्ड अच्छा द होल सेटअप इज टेकन इन ए सैटेलाइट इनटू स्पेस वेयर देयर इज नो ग्रेविटी अच्छा दीटा यदि पॉजिटिव चार्जेस बिकॉज ऑफ देयर म्यूचुअल रिपल्सन से माने इनिशियल केम थिबे इनिशियल डायग्राम इज लाइक दिस सो व्हेन दे आर टेकन टू स्पेस को नेला कौन हम से पचार स्टेट ऑफ वेटलेसनेस जोटा कि देयर इज नो ग्रेविटी स्पेस सो व्हाट इज द एंगल बिटवीन द टू स्ट्रिंग्स दीटा स्ट्रिंग भीतर बर्तमान एंगल अच्छे के लेट इट बी थीटा तो स्पेस को नेला पर एंगल केते होबो अच्छा देन व्हाट इज द टेंशन इन ईच स्ट्रिंग ओके ये चार्ज दिया केते कैपिटल क्यू बोथ को चार्ज दिया जी कैपिटल क्यू यस द लेंथ ऑफ द स्ट्रिंग इज एल एंड एल अच्छा जितना हमें स्ट्रिंग दीटा को नहीं जा को स्पेस को सो व्हाट विल हैपन इन दैट केस so in space gravity is absent yes so which implies so only force acting on each sphere is electrostatic force of repulsion this will be electrostatic force of repulsion only yes so the diagram will be like eta dita amar string thila yes here is one bob and here is another bob and this is the length L the length of the string is L and in this case the separation between two bob is 2L it becomes 2L this is charge capital Q yes so question kon pacharla what is the angle between the two strings the angle between two strings is 180 degree so for bit A the answer is 180 degree then next is what is the tension in each string so here remember electrostatic force of repulsion gives rise to tension okay so tension kon ethi here electrostatic force of repulsion gives rise to tension yes so we can calculate T is equals to that is Fe that is Ke Q into Q divided by separation between these two charged bob that is your 2L so this is 2L whole square so this will be Ke into Q square divided by 4L square divided by 4L square so this is our answer unit is Newton okay or you may represent in terms of 1 by 4 pi epsilon naught so this is about your question number 7 okay next come to your question number 8 okay two small spheres each of mass small m kg and charge q coulombs are suspended from a point by insulating threads each of length L meter but of negligible mass if theta is the angle of each string makes with the vertical when equilibrium has been reached then show that q square is this much हमको प्रूव करार अछि as per the given data q square value is this much so first draw the diagram as per the question two strings are there okay the diagram is like this previous रे करा हेतिला part 1 रो numerical ए type रो diagram last two numericals रही so first part 1 को देखो then come to part 2 okay so because question गुड़ा सेमती अरेंज ही then part 2 टा तुमको बहुत इजी लगे having mass m both रो mass देछि तुमको small m अच्छा they are in equilibrium. Now the angle made by the each string with vertical, that angle is given theta. Again आउ कौन देला तुमको देखो. अच्छा टू स्मॉल स्फीयर्स ईच ऑफ मास m kg एंड चार्ज q कूलम. एथरे चार्ज अच्छी बर्तमान q, एथरे भी चार्ज q. सो दी जन जा कौन करेंगे, जन जन को रिपेल करेंगे. सो दिस इज योर इलेक्ट्रोस्टैटिक फोर्स ऑफ रिपल्सन बिटवीन द टू चार्ज पार्टिकल. अच्छा L meter, the length of the string is L. Yes. So now each charge particle is in equilibrium. So equilibrium condition माने हम देखिबा तो कंपोनेंट कथा मु कहितली प्रीवियस क्लास. तो कंपोनेंट बर्तमान ताको स्प्लिट करिया देखो केमती जिनस आसुची. सो वेट mg is acting vertically downward, then along the string tension T is acting. I tension रो दुटा कंपोनेंट रहइबो. This is one component, this is another component along y axis and x axis. So mu कहि z format जोड़ देखिबा angle same रहइबो. So this angle is theta. So along y axis the component of tension is t cos theta and this will be t sin theta. I hope it is clear. Yes. And I would देखो from the vertical axis to charge particle the distance is let it be x. Here the distance is x, here also the distance is also x. अच्छा. So from the figure, as the charge particle is in equilibrium, as charge particle is in equilibrium, so we can write t sin theta value. T sin theta is equals to f and t cos theta, that is equals to mg. Yes. So now we can divide equation 1 and 2. So dividing equation 1 and 2, you will get t sin theta divided by t cos theta. This will be f divided by mg. So t gets cancelled out, then tan theta is equals to f by mg. Okay, tan theta equal to f by mg. So what is f value? First thing, what is f value? From this figure, what is the value of f? Electrostatic force of repulsion is 1 by 4 pi epsilon naught into charge of first particle is q, second also q, that is your q square. Q square divided by separation is 2x. Separation between two charge particle in as per this figure, the separation is 2x. Yes. So this will be 2x whole square. So the final answer is f is equals to q square divided by 4 pi epsilon naught into 4x square. Yes, 4 pi epsilon naught into 4x square. So we can write in this way. So which implies tan theta is equals to, tan theta value will be, f value is q square by 4 pi epsilon naught into 4x square. और तले थिला हमर केते mg. So from this हम प्रूव करे अछि q square रो वैल्यू. अच्छा. So इथरा हमर q square केते पेनला, q square is equals to केते आसला, और आंसर आसला 4 pi epsilon naught into 4x square into mg into tan theta. ओके. बट देखो हमरो गिवन डाटा रे किछि x रो किछि टर्म ही नाही. तब हम केमते अरेंज करिवा देखो इन दिस राइट एंगल ट्रायंगल. यदि हम राइट एंगल ट्रायंगल टाको भल से ऑब्जर्व करिवा. ओके. So what is the value of sin theta? Sin theta will be x divided by L. Okay, sin theta perpendicular divided by h, hypotenuse. So x by L. So from the figure sin theta is equal to, from figure sin theta is equals to x by L. So what is the value of x? X is equals to L sin theta. So which implies x square, amar it is x square term, x square will be L square sin square theta. Now put the value of x square. So this will be q square is equals to 4 pi epsilon naught into 4 into L square sin square theta, 4L square sin square theta into mg into tan theta. Yes. So hence proved. देखो ये टर्म टा ही तुमको पचारची as per the given question. 4 mg L square sin square theta tan theta into 4 pi epsilon naught. Kindly arrange कर दो ठीक से हो. Okay, and q value will be square root नहीं जो whole term रो. So this is about your question number 8. Okay, question number 8 complete है. ठीक से डायग्राम देखो. यू मे टेक द स्क्रीनशॉट एक्चुअली और पॉज करके तुम सॉल्व कर परिबा इन दिस वे. यस नेक्स्ट कम टू योर लास्ट क्वेश्चन ऑफ टुडेज सेशन. सो हमर आसिला given question the light particle of mass m and carrying a charge minus q1 is moving around a charge plus q2 along a circular path of radius r. Yes, so this is at the center tomar rahla ki center rahla amara plus q2 and a particle rahla minus q2. See this figure जोटा रिवॉल्व कर माइनस q2. ओके दिस इज योर माइनस q1 सॉरी माइनस q1 is revolving in a circular path of radius r. Okay, prove that the period of revolution, that means time period of charge minus q1 about plus q2 is this much. तुमको ऑप्शन सॉरी गिवन क्वेश्चन जो टर्म देछि ताको प्रूव करिया पड़े टाइम पीरियड वैल्यू एति आसुछि. अच्छा तो थरे से कोन रिवोल्यूशन कंप्लीट कला. सो टाइम पीरियड केते हबो वी नो स्पीड इज इक्वल्स टू डिस्टेंस कवर्ड बाय टाइम टेकन. यस so speed is v. so distance covered केते हला हमरो थरे बोलले 2 pi r divided by time जहा नबो सेटा हला टाइम पीरियड t. so time period t value is 2 pi r divided by v. so एटा हमरो टाइम पीरियड टर्म बाहर गेला कि टाइम पीरियड देखो एति नाही ऑप्शन रे ए सॉरी ऑप्शन कहूची गिवन क्वेश्चन रे. so फर्स्ट हम कोन करबा देखो pi टर्म अछि इन द क्वेश्चन pi is there हमर पे अछि pi. तो बर्तन देखो r is there हमर अछि r टर्म भी अछि बट आमर कौन नहीं देखो ये v टर्मटा गिवन क्वेश्चन डाटा नहीं. सो फास्ट आमको कौन करिया पड़ो v को कन्वर्ट करिया पड़ो अदर गिवन टर्म रे. ओके तो केमते हम ताऊ कौन टर्म करवा नाउ सी. अच्छा तो गोटे पार्टिकल बर्तन q2 अबाउट q2 q माइनस q1 इज रिवॉल्विंग. ओके तापर को फोर्स पड़थो रे सेटा ला तमर को फोर्स दैट इज योर को towards the center सेटा हला तमरो इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन इन द towards the center during the circular motion. एटा कोन फोर्स टा कोन कह जे दिस इज इक्वल्स टू सेंट्रीपेटल फोर्स. सो हियर Coulomb force of attraction between q1 and q2 minus q1 and q2 gives rise to centripetal force. Okay, so here I am देखिबा here force of attraction between minus q1 and q2 gives rise to centripetal force. बुझेला. तो दैट मीन्स हम लिख परिबा centripetal force fc is equals to fe. so centripetal force फॉर्मूला mv² r. fe वैल्यू केते होबो एठी 1/4 pi epsilon naught q1 magnitude that is minus q1 magnitude q1 plus q2 magnitude q2 divided by r square. सो बर्तन एथरा में v टर्म टाको बाहर करबे ठीक से. v टर्म को ठीक से बाहर करले केते होबो देखो एठी गोटे r अछि एठी गोटे r कैंसिल होला. अच्छा सो एठी हम पाइले mv² is equals to q1 into q2 divided by 4 pi epsilon naught r. Yes, so that means v² is how much? v² is equals to q1 into q2 divided by 4 pi epsilon naught mr. So what is the value of v? v is equals to q1 into q2 divided by 4 pi epsilon naught mr whole root over. This is the value of v. Now हम कौन करिबा से v रे वैल्यू को एठी पुट करिबा. v वैल्यू एठी पुट करिबा. सो यदि हम v वैल्यू पुट करिबा देखो v वैल्यू पुट कला पर कोन आसु आंसर देखो मो लेफ्ट साइड रे एटा लिखली राइट साइड एटा सॉल्व करछि सो दैट इजी हो तुम भाई. सी सो आवर टाइम पीरियड विल बी केते लिखिबा टाइम पीरियड t will be equals to 2 pi r. Yes, 2 pi r divided by v value q1 into q2 divided by 4 pi epsilon naught mr whole root over. So this will be equals to 2 pi r into 4 pi epsilon naught mr divided by q1 into q2 whole root over. अच्छा जब हम 2 pi r टा को बर्तन स्क्वायर रूट भितर को नबा तो तार स्क्वायर हे जिवो तले केते लिखिबा होल रूट ओवर 2 pi r स्क्वायर केते 4 pi स्क्वायर r स्क्वायर. इंटू जहाँ लिखा 4 पाई इप्सिलॉन नॉट एम आर डिवाइड बाय Q1 इंटू Q2 बर्तमान सॉल्व कले के देख 4 इंटू 4 दैट इज 16 नेक्स्ट इज पाई के पाई देख पाई स्क्वायर अच्छे पाई अच्छी दैट मीन्स पाई क्यू 16 पाई क्यू इप्सिलॉन नॉट एम इधर आउ गोटे जिन देख आर स्क्वायर अच्छे आर अच्छी दैट मीन्स आर क्यू एम आर क्यू yes divided by Q1 into Q2 whole root over. This is the value of time period. I hope it is clear. Now see T is equal to 16 pi q epsilon naught mrq 16 pi q yes 16 pi q epsilon naught mrq yes ठीक है the answer is correct. Okay, so in this way you can prove the time period as per the given data. Yes, so previous class रे part 1 numerical हमें somehow 13 numerical complete करथिले. Okay, एटे हमें 9 टा numerical complete कले. So regarding Coulomb's law एक different variety numerical हमें nearly 20-21 टा cover करथिले. Okay, so try to solve all these question. Okay, so kindly like, share and subscribe this channel. So thank you, have a nice day.